Okay, so section 7.4, once we've done section 7.3, there's no new information in this. We're just applying simplifying radicals, which we just did. So you're going to get the opportunity to practice this. So we're going to talk in this section about adding and subtracting radical expressions. So we're going to do that. So this is a flashback to probably 10 years ago in your math life, 9x plus 5x. When we go to add those, why can we add them? Because they are what? They're the same. They're like terms. They have the same exact variable part. So it's just counting. If I have 9 x's and then you come up to me and you give me 5 more x's, what do I have? 14 x's. Thank you very much. So 14x. Great. Didn't change the variable at all because I'm just adding the coefficients. So let's move to the right. We notice example 2. Example 2 is pretty much the same thing, except instead of x's, I've got 9 square root of 3's plus 5 square root of 3's. So if you had to guess, if your whole grade on this class was based on your answer to this question, which it's not, don't worry. But if it was, what would you guess is the answer to 9 square root of 3's plus 5 square root of 3's? 14 square root of 3. Notice, I don't change the radical at all. Okay, we're just counting them up. Okay, so I'm just going to make a little arrow here because this is the most common mistake. Don't change. It's not square root of 6. All right, with that knowledge, that's all you need to know for the next couple problems. So I'd like you to do exercise 1. Go ahead and simplify that expression. All right, if there's 11 square root of 7's and then we subtract 15 square root of 7's, what do we end up with here? Okay, -4, -4 what? Perfect, square root of 7. Great job. Anybody get something different that we have to talk about? All right, exercise 2 is just expanding our universe a little bit. So now we've got different things, we've got decisions to make, what are like terms and what aren't. So do exercise 2, please. So my first term is 3 square root of 5. What can I combine that term with? Yep, so these two are like terms right here, the -8 square root of 5. So if I have 3 of them and subtract 8, then what that is -5 square root of 5. Again, I'm not changing the radical at all. And so then the 4 square root of 2, I can combine that, I'm sure you would tell me, with the 9 square root of 2. So 4 plus 9 is positive 13 square root of 2. Are these like terms? Is square root of 5 the same thing as square root of 2? Nope, so you're done. Don't over combine. It's not square root of 7. You don't combine what's under the radicals. They always just say separate. Does that seem pretty clear? Okay, well, we're almost done. Okay, so the last few problems that we're going to spend our time with are just combining the skill that we learned in the last section with our remembrance on collecting like terms right here. So this is my last problem for the day that I'm going to do for you, and then you're going to have 4 examples of the same sort of thing to practice. So I got 6 square root of 24 plus 8 square root of 54. Are those like terms? No, clearly not. Square root of 24, square root of 54 are different. But before we give up and go to the next problem, we do remember that we can simplify radicals. We just learned it. Okay, so what we're going to do is we're going to see if I can make them into like terms by simplifying. Okay, so square root of 24. I think we already did 24, but we'll do it again. What's the perfect square factor of 24? It's 4 times 6. We'll come back to that. And then 8 times the square root of 54. What's the perfect square factor of 54? 9 times 6. Everybody tracking with me so far? Have I done anything mysterious? Okay, this is just what we did in the last section. Okay, we're just applying it now. And so let's continue on our simplifying. Now we're going to use the product rule of radicals. So underneath this radical, I can take the square root of 4. What's the square root of 4? 2. Okay, I'm gonna draw, I just want to notate this best for you. So I'm just going to draw a little arrow and I'm going to say, okay, that's 2 now. What do you think I'm going to do with that 2 and the 6 that was already outside the radical? I'm going to multiply it. So now I have 12 and then square root of 6. I want to pause because I did 2 things there. Everybody tracking with me, following along with what I did. All right, I heard some yeses. I'm hopeful. So here's what I'd like you to do. I'm going to give you 14 seconds. I want you to simplify the second term. All right, so I could take the square root of 9. What's the square root of 9? 3. So I'm gonna put a 3 right there to remind myself. And so then what's the coefficient outside of my radical now in that one? Yep, 8 times 3 is 24. And then the square root of 6 stays under the radical. What's wrong? Is that a question? No? Okay. Did these turn out to be like terms? Yep. Now it doesn't always turn out to be like terms, but this one did. So I've got 12 square root of 6s plus 24. That's 36. Square root of 6s. Done. There we go. All right, so the next problem, exercise 3, is pretty much the exact same thing. I just changed the numbers. So go ahead and give it a go. Ask me any questions that you have. If you need something, raise your hand. I'll run over to you. We'll get it worked out. All right, so let's give this a try. We'll correct any mistakes. And then exercise 4 is pretty much the same thing. I just added another term for 50% more fun. Okay, so here we go. I've got 5 square root of 12 minus 3 square root of 75. So as I'm writing this down, what's the perfect square factor of 12 that you used? Okay, 4 times 3. And then minus, and then the perfect square factor of 75. Okay, 25 times 3. Great. All right, so now I'm just going to change my coefficients. The square root of 4 is 2. And so what's the coefficient in front of this first radical? Okay, 5 times the 2 is 10 square root of 3 minus. Square root of 25 is 5. So what's the coefficient now? 15 square root of 3. Again, they turned out to be like terms because otherwise it wouldn't be as fun. So 10 minus 15 is negative 5 square root of 3. You got something different and you don't know why, you got plenty of time. Okay, so just want to make sure that you get this nailed down. Okay, so if you have something you need to talk to me about, raise your hand. I'll come to you. Meanwhile, let's take a gander at exercise 4. All right, I'm going to get started separating these radicals. You keep working. We'll compare notes. All right, so on this problem, the 50 becomes 25 times 2. The 18 becomes 9 times 2. And then the 98 is 49 times 2. So broke each of those up into its perfect square factors. And so again, these are going to simplify. They're going to try to be like terms. 25, the square root is 5. So my first coefficient is 4 times 5, or 20 square root of 2. Plus, there was no coefficient. There was a coefficient of 1, but no number in front of this one. So square root of 9 is 3. So I have 3 square root of 2. And then minus square root of 49 is 7. So 2 times 7 is 14 square root of 2. I just want to be doubly sure because I don't want to pass over this. Is everyone understanding why these coefficients become 20, 3, and 14? Okay. I'm hopeful. I want this to be an amazing last test grade so we can drop one of the earlier ones. So 20 plus 3 is 23, minus 14, I believe that's 9 square root of 2, and there's my answer. All right, the next one is absolutely no different. Those x's that are in there really don't even do anything to the problem, but I just threw them in there just to make sure we covered it. So go ahead and simplify that and collect those like terms. So on this one, there's no powers on the x's, so there's nothing to simplify on those. So they're just kind of there. Okay, if there were powers on the x, you would simplify them just like we did before. Okay, there's no new content. Once you've done your homework for section 7.3, simplifying these radicals is no different. So 20 is 4 times 5, and then I've got that x. I drew a really long radical there for some reason. I don't know why. Minus, and then the 45 is 9 times 5, and then that x is just there. So square root of 4 is 2. The 6 times 2 is 12, and I've got a square root of 5x. Square root of 9 is 3. And 5x, again, I have like terms as long as what's under the radical is exactly the same. If it's different in any way, they're not like terms, can't do anything. Okay, so 12 minus 3 is 9 square root of 5x. Oh, we've got one more problem. And then I'll be here if you have anything you want to hang out and ask me, because you're too shy to ask everybody. But always, whenever you have a question, somebody else has the same question. I guarantee it. Okay, so the last problem, exercise 6. Just notice I've changed the index. Instead of it square roots, it's cube roots. Okay, just to finish with a flourish here. All right, so cube root of 54 we did earlier, but you can remind me, what's the perfect cube factor of 54? Yep, it's 27 times 2. Great job. 16, this is a new cube root number than we've used before. What's the perfect cube factor of 16? 8 times 2. Great. You're just looking at that list, using your calculator, figuring out which one divides in. Okay, that's great. So just remember, we're doing cube roots now. Cube root of 27, that is 3. So I've got 3 times the cube root of 2. And then cube root of 8, that's 2. So I got 2 times the cube root of 2. And now those are like terms. They're both cube root of 2. They're the exact same thing. So I've got 3 of them plus 2 of them. That's 5 cube root of 2.